Okay, let's take a look at the solution to this example, talking about surface areas and volumes of solid shapes. An open rectangular box is made of wood 2 centimeters thick. The internal dimensions of the box are 70 centimeters long, 50 centimeters wide, and 30 centimeters deep. The first question is for us to calculate the volume of the wood. Let's take it from there first, for the volume of the wood. Now, what this simply means is that the box is made of wood, so that simply means the wood itself has a thickness which can be seen as a volume of the wood. So let's take a diagrammatic representation of what we are looking at. If I try to sketch out a rectangular box, remember it's a box, so it's a solid shape. So I can easily do something like this. And then let me have this as well. Okay. Let me take this. I think that should be okay. Then I would have this. And then this. Okay, let me take that again. Okay. Okay, I think I have it to be on. They should come this way up to the point where we have the same level with the other line that I have over there. So I think that's okay. So I can have this. Then I can drop this down as well. Okay. Then I can drop this way too. And then this can complete this side. Now this is a rectangular box, which I've been able to sketch, but you will observe that I have not shown the internal dimensions. This is just showing the external of this box. If I'm to show the internal dimensions, I'm going to have to do something of this nature. Maybe pick a point here, pick a point here, a point here, and then a point here, just to try to simulate the internal part of the box. And I'm making it a bit wide so that I'm able to show some other things, which is important to this question. So if I do this, okay, that shows the internal, that it has an inside. So I can also do this to complete the representation of the internal. So there are a few things we need to talk about. Number one, we have to talk about the dimensions inside the box. So which means, let me use a different color to show that. From this point to this point, which is from here straight down to the other end over there, is the length of the internal dimension, which was given as 70 centimeters. Now the breadth or the width of the internal dimension, that one is from here to here. So I can easily show that this way, from here to here. Okay, let's take note of that. All right, up to this point. That is given as 50 centimeters, internal dimension. Okay. Okay. Let me take it away from there and then simply put it a bit away. I think I'll prefer to put it this way so that I can use that side to show the dimension, internal dimension still, okay, so this is the breadth internally, 50 centimeters. so that I'm able to show the internal height right here, which is 30 centimeters. That's why I changed the place. I drew that. Okay, so very important for us to quickly take note of the fact that the box has a thickness of 2 centimeters. Now that means that from this edge to the internal, there's a thickness there, and that thickness is 2 centimeters. On the other end here as well, there's a thickness here from there to there, and that thickness is also 2 centimeters. Of course, you will expect that over here, from here to here as well, is also another thickness, which is 2 centimeters. And also on this side as well, that is a thickness as well, which is also 2 centimeters. Now, you need to relate the internal dimensions of the box to the external dimensions. How will you do that? From here, straight down to the other end here, can be considered as the external length, okay, how long it is externally, all right? And you will notice that the whole of that length will be a combination of the thicknesses around the internal dimension. So you're going to be having, let's say, that one stops somewhere here for internally, for the internal dimension. So the thickness 2 here, the thickness 2 here, then plus the 70 centimeters long internally should give the external length for the external dimension. So in other words, that will make you to understand that the external dimensions, so I will be talking about the external length, is expected to be equal to 2 centimeters plus 70 centimeters plus 2 centimeters. And that should give us 74 centimeters. Also, the external width or breadth will also be equal to, of course, you'll agree with me that that should also be 2 plus 50 plus 2 centimeters as well. And that should give 54 centimeters. Lastly, the external height, that's how deep the box is. The external height is going to be equal to 30 centimeters plus 2 centimeters, which will give 32 centimeters. Now, I know you'll be wondering why I didn't have 2 plus 30 plus 2 for the height. Now, the reason is because the question said it is an open rectangular box. So there is no lid, there is no cover on top of the box, which means there is no thickness on top, but there's a thickness below, okay, but no thickness on top. If it was covered, then yes, we would have had a thickness of 2 centimeters as well on top of the box. So without the cover, we only have thickness at the bottom of the box, not at the top. Okay, so finally, to find the volume of the wood which was used to make the box, so volume of wood must be equal to, just like you know from your previous lessons, the volume of external, okay, excuse me, the volume of external minus the volume of internal, minus the volume of internal. That is what will give us the volume of the wood that was used to make the box. Volume of external, yes, what shape do we have for this box? Definitely, this is a cuboid. So the volume of cuboid, remember, length times breadth times height. I'm using capital letters so that I can identify for external and small letters to identify for internal. Okay, The internal dimensions shows a cuboid inside as well. External also a cuboid outside. So external length, that will be 74 times width, 54, times height, 32. Then minus, for internal, you have 70 times 50. Let me take that again. Times 50, and then times 30 internally. So when we solve this bracket, we're going to have the following values. 74 times 54, and also multiplied by 32 should simply give us 12,000, okay, 127,127,872 minus, then you do 70 multiplied by 50 and also multiplied by 30, and that should give you 105,000. 105,000. So when you subtract that, you should get your answer to be equal to 228.72. 228.72. Remember, centimeter cubed still remains the unit of our volume. Okay, I think that is okay for us for the volume, which solves for question A of this example. Taking a look at question B very quickly, let's look at how we're going to solve question B. Now for question B, we're asked to calculate the mass of the wood. Calculate the mass of the wood. So let me just still demarcate this. I'm on the B part of the question now. We should recall very quickly that density is equal to mass over volume. That's the formula for density. Density equals mass over volume. So which means that if I'm to calculate mass, when I cross multiply this equation, mass will definitely be equal to density times volume. Density times volume. Okay. The density has been given to us in the question as 0.92 gram per centimeter cube. And the volume of the wood was calculated in question A above, and that gave us 22,872 centimeter cube. So when you work out this calculation, you should expect the centimeter cubes to cancel out, and then you do your multiplication of 0.92 times 22,872. You're going to expect that to give you 21,042.24. So 2142.24 grams. But take note that the question asks us to find that mass in kilogram. We're told that here in kilogram. So because of that, to convert grams to kilograms, you will need to divide by 1,000. So this answer divided by 1,000 should give us the result in kilogram, and that will give us 21.042 kilogram. You can approximate your final answer, telling us that this is approximately, let's just say 21 kilogram as your final answer. And that this is done to two significant figures for the final answer there. I believe this is very, very clear to everyone and very explanatory. Okay, an example on solving volume of a solid shape. All right, thank you. See you again in the next video to explain the next example on this topic. All right.